Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. This video today, right now, is just to kind of go over something I misspoke about in the previous video for the Day 21 Part 2. And basically, my wife knows that I'm wrong all the time, and that is true. I made a factual error when it came to the number of universes versus the probabilities of winning the game. So I jumped right in, even though I've done statistics and I'm still not a mathematician. And so for the problem, and again, this is presuming you know what you're doing here and you've already looked at part 1 and part 2 and you kind of know how to get things done. So when I run this program and I run this out over here, you can see that it's running through, it's the same stuff. Oops, where did it go? Oh, I hit a system pause. And you'll see that you have this number of universes are won by player 1 versus this number of universes are won by player 2. And then I went down here and I ran a comparison, and I was so happy to go, oh my goodness gracious, look at that. It's basically a 5 to 4 shot of a number of universes versus this. And I'm like, and I just went and my brain just went straight into going, oh, that's probability. And it's not. And the reason because I was wondering, because I spent some time doing this, I'm running this program right here. You can see this here, that I'm running the same program, but instead of running this as universes, I'm just kind of brute forcing this thing over time and just and you can see that this thing is running been quite a bit. It's it's Python, so it's not always the fastest. And this also gave me a chance, and there's no reason, I'm saying no reason not to just try out some new stuff and learn some new Python. That's what I've been doing these last 22.5 days or whatever, doing this kind of stuff. But again, you see that I'm getting 77% versus 56%. And it just comes down to the fact that universes don't, basically when you hit the end of a universe, you stop. But that doesn't mean that the probability of that universe has stopped being computed. I don't know. Again, I'm not necessarily a mathematician to decide this. But if you play a game of craps and you win on the first roll, that's basically you either roll a 7 or 11. That is 2 different universes. Either, let's see, 6 universes, you'll roll the 7, and then 2 universes, you'll roll the 11. But the game ends. But all the other universes keep going and going and going. So those numbers, those 2 universes that were just kind of done in one roll, you only get 1 out of that. But the probability is much different, because the probability of that is not just 2 universes out of millions, or of however many universes that craps game ends up in. It's 2 universes. It's 8 parts out of 36 total possible ways that the dice could be rolled. So right there, that's almost 25% or whatever it is. So you could see that that's where my mistake was, and I just wanted to make sure everyone understood that. And since it was a 24-minute video, I'm not going back and fixing that, and I will admit my mistakes and move on. But I learned from the process. So that is the whole reason why you get 56% of universes, but you get about 77.6% of winning, per se, percentage winning for player 1. And so real quick, then I just wanted to go through this too. So like I was like, if player is 0, make player 1, or if player is 1, make player 0. You can use a cycle, basically an iterable cycle, and this is basically a generator, a generator that's in itertools that it's already written for us. We could write this in no time at all as a generator for our own self, but that's just saying that it'll start off and it'll just cycle through from 0 to 1, range of 2, right? 0 or 1, and it'll start with the 0 in a cycle. 0, then 1, then 0, then 1. And I just have to make sure that I start it over from scratch every time I start my game. So that's why I'm cycle range 2, and then every time I want to change the player, or get the player, I guess, this starts out at player 0, because when I start a cycle fresh, the next number that comes is a 0, and it just, 0, 1, 0, 1, 0, 1, 0, 1. And so that's how that was working out. And then this guy here, this was the other thing that I was playing with and just trying out, this random.choices. I originally had a 27 element list and just told it pick one of those. But this is one way you can go ahead and say, hey, roll a 3-sided die. Here's a list of 1, 2, 3. those 3 items in the list, roll them 3 times, and then take that. This creates a list in itself of the values that were rolled of the 1, 2, 3, and this is with replacement, meaning that you can roll the same number for anywhere from 1 to 3 times. So some do with replacement and some do without replacement. But give me that list and then get me the sum. And so this is pretty cool stuff here. All the Python stuff is pretty cool. So I just wanted to show you things, if you're watching this video, that you might not have seen in other places. And again, great place to experiment on a rather simple example than to try to make some crazy part of Python work when you're already kind of shaky on trying to get a complicated problem working. So that's all I wanted to say for this. So thank you for hearing me out. And if you'd like to say anything down below, please do. Please comment below, and I'll get back to you as soon as I can. So, well, day 23 here. We're into the end, almost the end of everything here. So, Christmas time is Advent time, 25th is coming, and from there I'm going to move on to bigger and better things, or just at least different things. So thanks for sticking this out with me as always. Have a great day, everybody. Take care.